Okay, folks. Good afternoon and welcome to Sweet Thursday. Please excuse any technical glitches as we continue to learn this Zoom platform. We are on Zoom webinar, which is different from Zoom meetings, so we cannot see or hear any of you. The chat and raise hand functions are disabled, but Q&A will be open for you to ask your questions by typing them for our author. This talk is being recorded and you can view it later or send it to your friends on our YouTube channel, which is shown there. I'll try and remember to add that to the Q&A part later, so in case you can't write this down quickly. Sweet Thursday is the author series hosted by the Friends of the Lafayette Library. My name is Jeff Deeden and I'm the coordinator of the program. We have Zoom is our platform for the foreseeable future for both Sweet Thursday and Wonders of the World. Our next event is actually a combined effort of both programs. On Wednesday, March 2nd, Marilyn Chase will discuss her book about Ruth Azawa and her art. On March 8th, the Library Foundation Distinguished Speaker Series will host James Osland with a program about his Mexican cookbook, World Food Mexico City. On April 8th, author and swimmer Bonnie Sui will take us into the water with Why We Swim. And on April 14th, WOW will host art director Avril Angevine, art educator Avril Angevine, who will discuss the photography of Dorothea Lange. In order to learn about all our programming, you can sign up for weekly emails, which describe our upcoming events on the website shown here, llcf.org/subscribe. The library is open, but only for checkout. You can't go in the building, but you can go on the website, check out books, and get curbside pickup. For other programming at other Contra Costa County libraries, you can go on the county website, which is ccclib.org. There we go. In pre-COVID times, the Friends Corner Bookshop sales supported a number of programs and services at the library. These include librarian salaries for Sunday hours, books and other materials, library programs, Friends programs, and also support the Library Foundation and the Historical Society. The bookshop remains open for curbside pickup, but you can't actually go in the store. You can call and inquire about available books and get your books at pickup. We are not yet able to accept book donations. I'd like to thank the Friends, the library staff, the foundation, and my Sweet Thursday committee members. You can get a copy of Dr. Horowitz's book at Orinda Books, who support our programming. You can check out their website here or call to order it. Now for our program. Tonight, I'm pleased to welcome Dr. Barbara Horowitz to the Lafayette Library and Learning Center. Dr. Horowitz is a cardiologist and evolutionary biologist with academic appointments at UCLA and Harvard Medical Schools. She received her undergraduate education at Harvard, followed by medical school at UCSF, and then her residencies in both psychiatry and internal medicine, followed by a specialty fellowship in cardiology. She balances teaching undergraduate and medical school courses at both UCLA and Harvard with her writing, research, guest lecturing, and other responsibilities. Her first book, Zubiquity, also co-authored with Kathryn Bowers, launched a series of Zubiquity conferences with far-reaching goals and work. Since 2011, their mission is to accelerate biomedical innovation by bringing together leaders in human and animal health, evolutionary and conservation biology, and ecology and public health for focused and strategic collaborations aimed at solving high-impact human and animal concerns. In 2019, Dr. Horowitz was invited to speak at a Zubiquity Symposium at the prestigious Karolinska Institute in Stockholm. Their new book, Wildhood, explores the many common behaviors of animal and human adolescents. It follows a focused, but in my opinion, occasionally meandering path to make their points, following the lives of a number of animal characters in the process, 4 in particular to underscore the 4 pillars of life skills that an animal must master. It is semi-academic, but uses stories to engage the reader and is easily understood by a non-scientist. Yet, it introduced many new terms with which I was not familiar. Ultimately, their thesis is that we humans, at our most vulnerable stage in development, share many behavioral traits with our non-human animal partners that we can learn from these commonalities. I'm really looking forward to tonight's presentation by Dr. Horowitz. It'll be a little different from many of ours in that it's not going to be conversational. She has a very engaging presentation for us. So pay attention, and you can add your questions to the Q&A function at the conclusion of her presentation. I'll start off the questioning, but then we'll pick your questions off. So now it's time to introduce or to actually show, let me stop my screen share, show Dr. Horowitz. Welcome, Barbara, to the library.
Thanks so much. I'm really excited to be here and delighted to talk about species-spanning medicine, focusing on adolescents, and to get some good conversations going. So I'm going to share my screen. And here we go. And are you seeing species-spanning medicine?
Yes.
Excellent. All right. So the premise of my work is that by looking across species and evolutionary time, we can better understand the cause of human pathology, broadly defined, and we can accelerate innovation. And finally, we can become more humanistic. And I'm going to make the case for that today, but I don't have that much time, so I'm going to sort of do this in a very abbreviated form, starting with a kind of whistle-stop tour through my own journey. And but before I do that, I want to ask everyone to do something that I ask all of my students to do on the first day of class, and that is to check your human exceptionalism at the door. And I say that because I believe human exceptionalism is a blindfold. It is a blindfold that has prevented us from recognizing connections that exist across species, which when visualized allow us to understand the origin and some of the essence of our human vulnerabilities. So my own journey quickly is that I was a cardiologist at UCLA for a couple of decades. I was working particularly in cardiac imaging and with our arrhythmia group. And one day I got a call from one of the veterinarians at the Los Angeles Zoo. And they had a chimpanzee who had a neurological event, and they wondered if I would come and do an imaging procedure that we do all the time on humans who have had a stroke, let's say, to rule out or to identify some cardiac source for the stroke. And so, I mean, what an exciting thing to do. So I remember that first day very, very well. I got to the zoo hospital, and there was my patient, Pandora. She was sedated. The breathing tube was in already. And that probe that I'm holding is an ultrasound probe, which is used, every day around the world on humans. And it's a little ultrasound crystal. I slid the probe down the chimpanzee's esophagus to take a close look at her heart. And I'll tell you what I saw in just a moment. But what I saw created a real light bulb in my head. It was an aha moment that really did transform how I see human medicine, and then really transformed my career. But in those early days, I was being called for, a chimp. There were gorillas who they screened for a tear in the aorta. So an aortic tear is it's It's seen in humans as a form of cardiovascular disease, very serious, but Western lowland gorillas in captivity are also at risk. And I should say that there are, the veterinarians at the LA Zoo and at zoos around the country are highly trained, board certified. They take outstanding care of their animal patients, but from time to time, they do reach into the human medical community for certain kinds of procedures. And I was one of those lucky physicians who got to come to the zoo and working under the supervision of the veterinarian participate in the patient's care. I did graduate beyond the primates, and this was actually a really wonderful moment, a post-operative check. This lion had actually had a significant collection of fluid in the sac in which the heart is contained. And that large volume of fluid was preventing her heart from functioning properly. And we did this procedure with veterinarians and physicians. And anyway, she did very well. Well, let's go back to that chimp that first day. Her name was Pandora. I put the probe down, and this is what I saw. And for those of you who don't read echocardiograms, this is a cardiac ultrasound. And you can see that there are 4 cardiac chambers. This is a chimpanzee, right? Left ventricle, right ventricle. And these upper chambers are the atria. And I don't know if you appreciated it earlier, but take a look again. You see these bouncing balls over here in the right atrium? These are blood clots. And Pandora had lots of blood clots in the upper chambers of her heart. And the moment I saw this, it reminded me of a human patient whose echo I had done some months before with blood clots, the same changes. And I realized that this human and this non-human animal had the same form of heart failure. And in all of the years that I'd been teaching about this problem, I'd been taking care of patients with this problem, I had really not given any thought to other species who might naturally, spontaneously develop this issue. And the aha moment that I had was, how could I possibly not have thought about that? I mean, why? It seemed my ignorance really was what the light bulb was about at that time. Well, over the next several years, I started, I was going to the zoo. I was taking care of a wide range of patients with problems like breast cancer, lymphoma, and leukemia, a range of cardiovascular disorders, and even some biobehavioral disorders, what we would call psychiatric disorders. And I'm going to get to that in just a moment. But I really had an increasing urge over the years to find a way to take this experience, this growing recognition of the shared pathologies of humans and non-human animals, and somehow bring it back to my practice as a physician, my teaching as a professor. I wanted to see what the connection to human health would be. And so Kathryn Bowers and I, who have co-authored the books together, and we were part of this now more than a decade-long partnership, we founded the Zubiquity Conferences to bring together veterinary and medical school faculty and students. This was actually the first of the Zubiquity Conferences, and this is the handshake that we really sought to replicate around the world and have. This was the then dean of the UCLA School of Medicine, Human Medicine, and this was the then dean of the UC Davis School of Veterinary Medicine. Well, initially, I thought, well, you know what? I'm going to write a book about physical diseases, heart disease, cancer. You can see these other diseases. And I really hadn't thought at all about mental illnesses, mostly because I didn't know at that time that psychopathology occurred in other species. But boy, did I learn a lot. And boy, has this transformed how I think about everything from mental health to normal development and the impact of environments on how we feel. This is actually a disorder called feather plucking disorder, a very severe case, as you can see. And this bird has essentially plucked all the feathers out of her thorax and parts of her wings. And this is, we'll talk a little bit about that in a bit. This is another, again, I was learning on and on and on as I was going to different veterinary conferences, wild settings, interviewing wildlife biologists, all kinds of people. This is an example of a pacing compulsion. And these two polar bears are, it's entrained. In other words, they're sort of synchronized. And this is not the topic of this lecture. I give other lectures on mental illness in other species and the connection to human mental health. So in any event, I was really realizing across this journey that mental illness was certainly not uniquely human. And I had all these unexamined assumptions, my own human exceptionalism, and ultimately the book was half psychiatric, biobehavioral disorders, and half physical disorders. Well, in the beginning, I was eager to make a connection to human health. In other words, to sort of say, well, what is the significance of the occurrence of breast cancer or compulsive disorder or separation anxiety or what have you? What is the significance to human patients? But it was not such an easy thing to do. And I tried a number of approaches. But I then was very lucky to have heard a lecture, and I was reminded of the work of this man. And his name was Nicholas Tinbergen. And I'd actually studied his work when I was an undergraduate, but hey, that was decades before. Well, Nicholas Tinbergen was an animal behaviorist, and he, along with two other animal behaviorists, was awarded the Nobel Prize in Medicine in 1973. And Tinbergen, his contributions, there were many of them, but what most people remember him for is the following. Tinbergen recognized that most explanations for a behavior or some phenomenon in biology were very reductive. They were mechanistic, right? So think about human medicine. If somebody would say to me, oh, somebody comes into the emergency room with a heart attack, accompanied by their partner, the partner says, why did my husband have this heart attack? The typical answer that I would give as a cardiologist might have been, well, there was some atherosclerotic plaque in the coronary artery and a blood clot lodged. So it would be very much a description of what had happened. Well, Tinbergen recognized that that was more of a description and not really a why explanation. And that to really answer the question why, one needed to ask the evolutionary question. How is the vulnerability to that problem? How might that have provided biological benefit? And in order to answer that adaptive, that evolutionary question, it was necessary to look phylogenetically. And that term phylogeny refers to the models that are used by evolutionary biologists to see the relationship between species and their characteristics. This, of course, is everybody's favorite phylogeny, and it was Charles Darwin's sort of scribbles, and this is 1837, so this is many years before he actually published The Origin of Species. But you can see the trunk, the common ancestor, you see the branches, et cetera, et cetera. And my favorite part of this phylogeny, of course, is the humility right up here. I think, he says. In any event, you can, now you know what a phylogeny is if you didn't before. And I started to do these studies where I looked for the occurrence of what I had assumed to be uniquely human problems, such as atherosclerosis, the cause of heart attacks and strokes, in other species, and build these phylogenies, right? You can see that this is the kind of a tree of life, essentially, where you see how the speciation occurred. So atherosclerosis, I started looking at the cancers that are highly associated with modern human lifestyles, breast cancer, lung cancer, et cetera. And so I was doing quite a lot of that. Well, to cut to the chase, what was the purpose of doing that? And how could that help me connect what I was learning to human health? And let me explain what I came upon. So I looked at a lot of potential problems in human medicine to use this approach. And the one that really worked, the first one that really worked, was using this phylogenetic, this evolutionary kind of species spanning perspective to explain a kind of fainting that sometimes happens in people. It's got a term, a medical term, but it's essentially a kind of fear or high stress triggered fainting. Now, I used to teach the second-year pathophysiology course for the medical students at UCLA, and when I would talk about this problem, I would say, well, why should fear cause fainting? And I would suggest that it was paradoxical. Why did I say it was paradoxical? Well, What do you expect when someone is frightened, right? We think of the fight, flight, right? The sympathetic response that when fear should create, one would think, a rapid heart rate. But what we see with fear-induced fainting is a sudden slowing of the heart rate, which leads to an inadequate amount of blood to the brain, leading to fainting. Okay, now, as it turns out, it's only paradoxical if you have an anthropocentric approach, right? If you have this Homo sapiens centrism, which, guilty as charged, before I had what I call my ubiquitous epiphany and journey, I certainly was not thinking about the causes of these problems from an evolutionary perspective. But I began to, for this particular problem, I decided I would see if I could build a phylogeny of slowing of the heart in response to fear. And in fact, what I was able to do was to identify a pretty broad range of vertebrate species, right? From mammals over here, through birds, through some amphibians and reptiles, and even fish, in which occasionally fear could induce a slowing instead of an accelerated heart rate. Well, once you see a trait that is conserved, or at least is widespread, there are all kinds of questions that you can ask. And I mean, look at the phylogenetic, how broadly this trait exists. Well, I came up with ultimately an adaptive hypothesis because I began looking at studies that had been done by wildlife biologists decades before, and things started to click into place. This is a young deer, right? A fawn with the white spots. And in one study that was really relevant to my thinking about things, they put EKG leads on this fawn. They then played, these are wolves, they played recording of wolf howls. Maybe you can hear those, which was very scary, would be very scary to this young deer. And the heart rate plummeted from about 200 beats per minute to about 50 beats per minute. And this was what ensued. Now, the loss of motor tone, the tonic immobility, right, the stillness, all of this suggests to me that this was a fainting, quote unquote, episode. I can't prove it, but I suspect that it is. And all of a sudden, you are probably beginning to kind of formulate a hypothesis about why this might actually be fitness enhancing. That for a young animal who might not be able to mount an effective flight, they're not strong enough or old enough, that having a slowing of the heart in response to fear, leading to this motionlessness, which creates, it's a form of hiding, really, might be the most adaptive thing to do. So I'm going to just quickly play a video, and then we're going to get to adolescence a little bit more specifically. But in the video, what's happening is there's a cheetah who is actually taken down an impala. A young cheetah has taken down an impala, but then a mature hyena spies the young cheetah with the impala. By the way, don't worry, this has a quote unquote happy ending. And the mature spotted hyena intimidates, and this happens obviously a lot, intimidates the younger cheetah out of the way and begins to, basically take the meal. Now, what is going to happen is the cheetah returns, the hyena leaves, and I want you to keep your eye on the impala, not the hyena. Okay. So that's pretty compelling evidence that tonic immobility is life-saving, can be life-saving. And although I don't know whether this particular ungulate, this animal, had a slowed heart rate or not, in this particular taxa, it's a pretty common phenomenon. So I hope that I have sort of shown you quickly that there is a way of using this phylogenetic, this species-spanning approach to expand our understanding of maybe why and how, why we're vulnerable to certain processes and how that evolved. Well, let's now take that, that approach and let's apply it to some of the common adolescent challenges. I've been really interested in this since Kathryn and I wrote Zubiquity. Zubiquity was published in 2012, and the second to last chapter in Zubiquity was actually about adolescence in animals. And so we had become very interested in exploring this topic more. we were working on the book, we were traveling around the world, we were doing all kinds of things when I left from UCLA to Harvard and began teaching a course called Coming of Age on Planet Earth in the Museum of Comparative Zoology, which was really wonderful. We looked at adolescent animals, etc. And the point is that the point of the work was really that by looking evolutionarily, we could understand aspects of modern human adolescence that might impact physicians and others who are charged with taking care of young humans. And of course, our book, Wildhood, was the product of that. Well, we actually start the course by talking about Margaret Mead. And Margaret Mead, of course, was one of the great, probably most famous public intellectual of the 20th century. And Margaret Mead, of course, was an anthropologist. And for her PhD dissertation, she was sent to Samoa to study adolescents, particularly adolescents in these females. And she ends up writing Coming of Age in Samoa. And we actually start the course by walking to the Tazer Library, where we look at a first edition of her book. And we talk about Margaret Mead because Margaret Mead was using the comparative approach to understand adolescence. Her comparative approach as an anthropologist was to look across human cultures. Our comparative approach was to look across species. Now, we began thinking about all of the problems, the challenges that are associated with modern adolescence, challenges like eating disorders. And we asked questions like, what can self-induced vomiting in a gorilla teach us about self-induced vomiting and other eating disorders in adolescents? What can bullying among, let's say, pigs or other animals that live in hierarchies, what can that teach us about the origin, the nature of bullying in humans, and particularly in middle school and high school? We spend quite a lot of time writing, and we've done a lot of work on bullying and the using an animal framework to really understand the motivation of the bullier and some of the responses of what are called the target animals. That's what the wildlife biologists call those individuals. We even were able to find some really interesting connections in the animal kingdom to things like binge drinking. And these are actually cedar waxwing birds who flew into, they died obviously, they flew into a building because they were intoxicated, and they were intoxicated because they were gorging on these fermented berries. And this was given to me by Emily Beeler, who's the public health veterinarian in Los Angeles. And this is something that is, happens, not that infrequently. Well, what I'd like to do now is to use the same approach that I showed you for coming up with an explanation for fear-induced fainting, but apply it to adolescent risk-taking. Everybody knows that adolescents take risks. It's almost a trite, we say, we wring our hands, we say those adolescents are such risk takers. This knucklehead, I mean, it's hard to, I could watch this video over and over and over again. It always has the same impact on me. But risk-taking is a very significant part of adolescence, and the consequences of risk-taking, among the consequences are a substantially elevated death rate for teenagers, 12 to 19 years of age. So down here is 12, you see up here 19, and you see whether we're talking about both sexes, which is this gray, or male or female, you see that the mortality really increases. And this is a very puzzling trend as an evolutionary biologist, right? Why would young human animals have a neurobiology that would drive them to take risks which were associated with a 6-fold increase in mortality? These are pre-reproductive animals, right? One would expect, as the evolutionary prediction would be, that there would be strong selective pressure against this. So what the heck is going on? Well, before I had my ubiquitous journey, I, like most physicians, and I was a psychiatrist before I was a cardiologist, if you'd asked me why teenagers take so many risks, I would have explained what I now realize is a proximate explanation. Nico Tinbergen would not have approved. I would have explained I would have said, well, the teenage brain has these unique characteristics. And this New Yorker cartoon, young man, go to your room and stay there until your prefrontal cortex develops. I show this to my students who are, 18 to 22, and they laugh because all of them have heard at some point in high school that the adolescent brain is quote unquote underdeveloped, right? And the model, and I'm sure most of you have heard about this, is that the prefrontal cortex, which is sort of the restraint, the governor of the brain, that the PFC is late in maturing, right? So that you have this kind of lag, so that in adolescence, the parts of the brain that are emotional and impulsive are really developed, and yet the container of this, the regulator, isn't developed, and so that mismatch results in behavior which is risky, and that ultimately, as an adult, the PFC is more mature. Well, that is all of that is fine, but is there a perspective that can help us understand this increase in adolescent mortality that involves looking across species? And so what I did was something called a systematic review. To make a long story short, I looked at nearly 1.5 million records. These are studies that have been done on animals, from fish through mammals, and to identify studies in which there was some information about the mortality of an adolescent animal versus a juvenile or a mature adult. And in fact, I was able to find, this is another kind of, it's a phylogeny, right? It's a family tree, common ancestor. And all of these yellow bands are species in which I was able to find evidence that young adolescent animals, so this would be birds that are fledging, right? They're old enough to leave the nest, but they're very inexperienced, or dispersing animals, right, who are leaving the natal burrow. They're big enough and mature enough to be now outside of direct parental protection, but they lack experience, etc. And in fact, it's a very risky period across vertebrates. Adolescence is. There's plenty of evidence for that. We actually, Kathryn and I reviewed several large series that looked at roadkill. Remember, there are at least 1 million animals who are killed every day on American roads from roadkill. And we were able to establish that they are disproportionately, not exclusively, of course, but disproportionately younger, newly independent animals. And maybe some of you remember this. This is a video from a drone photographer. This is an adolescent humpback whale who was really trapped in Ventura Harbor. And in fact, we've talked with a number of wildlife biologists who've indicated that when wildlife ends up in an urban area, and it's obviously very dangerous for the animal, she happened to survive, but just by really kind of amazing luck, that very often they are adolescents, that they've become separated from the group, and they lack the experience to refrain from doing dangerous things or to get out of harm's way. Interestingly, and kind of in parallel with the roadkill story, whale strikes, which are a very significant issue because of busy shipping corridors, whale strikes are also impact disproportionately newly independent whales. There are some hypotheses that as whales mature, they become more experienced at recognizing the sound of an approaching ship. The point is, being young is a risk. The other reason that one of the other reasons that young animals are at increased risk is that they are inexperienced. They are, there's a term that's used by wildlife biologists to describe newly independent animals, and that word is predator naive. Because they're predator naive, they're really easy prey. They, many predators camouflage themselves, and as animals get older, they're able to recognize that. But when they're young, they may fall for it. They also, because they are not as big as adults and inexperienced, they're targeted by a number of predatory species. So killer whales, for example, do feed on humpbacks in certain, there are different kinds of orcas, but and who feed on different kinds of food, but certain ecotypes of orca do feed on humpbacks. And in this study, you can see that there was truly selective predation on these subadults, what we would consider adolescents. You can see, I've circled it, that the subadult, you see one calf, and then lots and lots of subadults and one adult. And we could talk more about that. We were able to find quite a number of species that do selectively prey on adolescents. Now, there are some interesting adaptive strategies that are used by adolescent and animals to become safer. One of these is called predator inspection. The meerkats that you see on your left, the first one was an adolescent. This is a mixed age group, but they're actually approaching rather than fleeing from this cobra. This is an example of, it's two things. It's called mobbing, but it's also predator inspection. And meerkats do this to learn about what's dangerous. They are smelling, they are watching. The young ones participate along with the older animals. And the idea is that there's value in understanding the dangerous things in your life, even though it may be dangerous getting the experience. On the right, I'll show you some wonderful example of predator inspection, same phenomenon. You see these cheetahs here in the foreground, and in the back, you see that there are these ungulates, these hoofed animals called Thompson gazelle. And cheetahs are one of the most important predators for Thompson gazelle. And what you're going to see in a moment is something pretty remarkable. You're going to watch as the young Thompson gazelle comes toward, as opposed to flee, instead of fleeing. And you'll watch others do the same thing. So here we go. This one approaches, this is a young animal. And now they're all watching. Look at them. They're staring at the cheetah, smelling, learning. This is predator inspection. They're gaining information. They're three, and boom, they're spooked and off they go. But that is really an educational behavior, predator inspection. And we read about that a fair amount in the book. I want to wrap things up so we have time for questions. And I can actually pause for a moment, maybe, if that makes some sense, and I can resume. Maybe that would be a good thing to do.
Okay, that was cool. Those videos always bring things to life. First thing I just want to say is Devora says hi. Devora Citron. I'll start off with a couple questions. You touched on several things, but what in Wildhood, what are the 4 core life skills that you primarily focus on?
Right. So we ultimately came to this kind of, by the way, our methodology, we had a number of different methodologies, but mostly we did these systematic reviews where we looked at the published literature to identify causes of mortality, causes of what caused fitness to be increased or decreased, to sort of see whether there were characteristics which were common to animals in this developmental phase of life, even if phylogenetically they were very separate. And what we found is that there were 4 core competencies that if a young animal was able to really master them, then she would end up as a mature adult. And if he didn't, he would not. And those were, first, learning how to stay safe. So you saw a moment ago that being an adolescent animal puts you're at risk. Your mortality is higher than any other phase of life, with an asterisk, but most of the time it's one of the highest mortality periods. You need to learn to recognize what's dangerous. You need to learn how to evade danger. Adolescent animals need to learn what's called the predator sequence. In other words, they need to understand the behavior of their hunter if they are the hunted. The second core competency is social. They need to understand how to navigate social hierarchies. And we found some really interesting information about how young animals learn to recognize their place in a group, what determines an animal's rank and status, and how friendships are formed, And some of this stuff was interesting, but exciting because of the universality of it. In other words, we were able to find the same trends and patterns in fish, in birds, and in mammals. So it was really interesting to see this kind of horizontal continuity across these species. The third core competency, which we can talk about a little bit, is sexuality and learning to sexually communicate. One of the most interesting and surprising things that I learned, well, animal sexuality has been a big part of my courses even before Wildhood. And in the olden days, 5 or 6 years ago, a big part of the story was just, kind of breaking the story of non-heterosexual sex in the wild, which is now an old story, but and sort of beginning to understand, what, kind of the spectrum of sexual behavior and the purpose of it, really, the adaptive function of both procreative and non-procreative sex. And there's lots of non-procreative sexual behavior in the wild. But when it came to adolescence and thinking about what an adolescent animal needs to learn, mostly they need to learn the language of courtship. There are birds, and I can show you some videos, but there are birds that, for example, some of these albatross, it can take them 5 years. So they are already, they've fledged, they're adolescents, right? Their bodies can make offspring, but they won't mate. They won't have a mate until they learn these dancing steps. It's an elaborate courtship ritual, and it can go on for years, right? The training. Similarly, there are a number of species where an adolescent bighorn sheep, for example, he may be physically mature. He's been through puberty, right? And by the way, we have a whole section on puberty, which is highly conserved, how it starts and what happens. But because only one male is the breeder, young adolescents may not have sex. They may not mate for a very long time. So what I had previously sort of assumed, again, my human exceptionalism, unexamined assumptions about the way things were in the wild, I thought in the wild, animals go through puberty and they start having sex and they start having offspring. And while that is true some of the time, it is not true much of the time. So there's a period where animals need to learn the language of courtship, and that is a core competency. And the final fourth core competency of adolescence is learning how to feed yourself, figuratively and literally, becoming independent, learning how to hunt if you're a hunting species, learning how to find food, and really learning how to kind of put all of the competencies together and make it on your own. In our species, we now, we all of us know people who are chronologically adults, but they lack at least one of the core competencies. They can't take care of themselves. They haven't learned to communicate either sexually, or they haven't learned to navigate social hierarchies. But what's different in the wild is that if a wild animal doesn't master all four competencies, they won't survive. So in that sense, there's this way that we can really learn from wild animal adolescents about what the stakes really are.
I'm going to read something from your epilogue that puts a little asterisk on that regarding the sex maybe being an exception, that I thought was a good wrap up. You say, creating offspring that survive and reproduce is how biologists measure the success of penguins, hyenas, whales, and wolves, which are your 4 species. But for humans, reproduction is not the measure of successful maturation. Staying safe, navigating hierarchies, communicating respectfully about sex, not necessarily having it, and learning the satisfactions of self-reliance are the true markers of adulthood. Acquiring the 4 life skills of wildhood prepares us for many kinds of adult success, from the professional and the public to the personal and private. I think that's a good synopsis of just about everything. I don't know if you want to comment on that before I ask another question. But...
Yeah, no, I have to say, we were writing, both Kathryn and I had adolescents when we were writing the book. Mine are a little bit older than hers, but I have to say that but when we were done, by the time we were done writing the book, I almost every day was thinking about situations I would have handled differently, kind of a way in which I would have framed certain kind of challenges my kids were going through a different lens, kind of seeing them more positively. And I think the idea that there are these competencies, so our kids, you know, if they go to high school and they have to get good grades and they need to get into college, and a lot of what they're occupied with when they're, you know, in our homes is stuff, are accomplishments, let's say, that are determined to be important. When you kind of take a step back and then maybe another big step back, or maybe 10,000 steps back, and you start looking broadly at what's important, the core competencies start to make a lot of sense, and shifting what we're teaching adolescents in schools and in our homes seems like a pretty good idea to move in that direction.
Yeah, I think the understanding might help cut them a little break once in a while. Actually, I was reading the chapter on sex while my wife and I were vacationing just a few weeks ago, and we took a whale watching boat. And you use Salt is the name of the female humpback whale in that section. And the boat driver was a teeny little boat, and there were just a dozen of us on it, hauled butt because they heard from another boat driver that there was a competition pod, what you call a rowdy group, going on. And we've done this multiple times, and usually it's a few males chasing a female. And I won't talk all about it. This one there were 10 of them, and they were exhibiting some crazy behaviors in trying to sweet talk the female. So why don't you tell us about rowdy groups?
Sure. Yeah. In fact, I'm trying to find the videos where I can show you. I have some great videos of that. But yeah, so Humpback Courtship is so interesting. The females, first of all, humpback sexuality is absolutely fascinating because of the singing, right? The phonation. So you've got these males that come together in these choruses, and they kind of collectively produce this really powerful sound. And the sound travels, hundreds, if not thousands of miles. I have not gotten a clear sense on what the outer bounds of the distance are, but the singing travels across the water, and it hits the female body. And the vibration or the sensation of the music, of the sound, causes her to sort of turn in the direction of the sound of the music and swim in that direction. Interestingly, there is evidence in a couple of bird species that male birdsong can actually induce ovulation in females. And we did encounter a couple of papers from the cetacean literature that indicated there's some suggestion that the humpback whale, the male song, can induce ovulation in the female, but that's not proven. So then they all sort of they all meet up. In the case of Salt, who is a humpback on the northeast corridor, right, Cape Cod and in that region, she starts to swim south, and they all meet up around the Dominican Republic in the water down in the Caribbean, where they have these heat runs. And these are high intensity, fast paced, they're sort of displays, competitions, but the female is the pursued, and these males, they swim at high speed. It's almost like one of those Formula One races, right, where they're just going at high speed. And there was an underwater wildlife videographer who actually got himself in one of those rowdy groups and just described it as the most terrifying thing, in his life. But it's a pretty amazing spectacle. And this female Salt has had a calf almost every year. She's had lots and lots of calves, and the fathers, because they are able to do paternity testing, some of them have come from Finland, Denmark. Some have come from, they cross the Atlantic. So it's just mind blowing, the complexity and the elegance of courtship. But it takes a long time. By the way, those adolescent males, when they first join those choruses, their singing is terrible. And there is a marine biologist who was studying humpback songs for years, who said that the clunkers, when you hear the notes that aren't quite right, it's typically the adolescent males who haven't developed the lung capacity to really do it right. So it's pretty incredible. I wanted to show you a video to show those albatross I mentioned. Is that okay?
Yeah.
So here we go. Are you seeing albatross, or what are you seeing here?
No, it's just a multicolored thing.
Okay, here we go. This should work.
There you go.
All righty. So these adult Laysan albatross, look at this beautiful synchronization. The beak fencing, the twist and turn, the neck extension. Now, these are adolescents, and they're trying to do the walk, right? They look like, seventh graders at the junior prom. And now they're going to try a little beak fencing. They're not very good at it. A little twist and hold. These are actually Galapagos albatross, a different species of albatross. And the adolescents watch the adults engage in this activity. There's a lot of learning from older animals. So in any event, that learning how to do that dance in that coordinated way can take years. And so during that period of time, they're adolescents, but they are not having sex.
Okay, I'm going to hit a couple of the audience ones now. In animals, are the females less risky than the males?
Yeah, it's my favorite question, and I don't have an answer for it. But in my work, I increasingly focus on, I tilt toward thinking about female health. In fact, my current project is called Female Health Across the Tree of Life. And unfortunately, I don't know. They're in most of the wildlife studies that we looked at, gender, sex is not even given very often. There's a kind of default assumption that the animals are male. And so I don't know. But my prediction would be that there would be differential, some difference, maybe skewing the same way we see greater risk taking in males than females, maybe not.
I would imagine to be species specific. In matriarchal societies,
That's right.
The hyenas,
That's right.
it's probably a flip. And
that's a good point. Yep. Those hyena queens, hyenas they are really aggressive and they are very bold. And I agree. And that's probably right.
That was a fascinating chapter. All that stuff about just, the way that kid, what was his name?
Frank. Yeah.
Yeah. How he increased his status. That was really a great exploration.
These guys, these wildlife biologists, there's this German team. I'm forgetting the university that they're from, but they're from a university in Germany. And for 30 years, they have been in the Ngorongoro crater studying these clans of hyenas, of spotted hyenas. And they are able to trace, they know the lineage. It's like some, master genealogist, so-and-so begat, so-and-so begat. They know everything about what happened in their lives. And so when we were interviewing Oliver Honer as the principal investigator, it was like he was talking about, we would ask very specific questions about these hyenas' social lives and sex lives. And boy, they have so much information.
Yeah, that brings up a question I had. You clearly do a lot of field research, but some of these things you couldn't have done. I don't imagine you followed Ursula, the king penguin, but relied on other people's research.
Right.
How do you divvy that up and choose what to use in the book?
Right. So we used 4 animals to illustrate, 4 actual adolescent animals to illustrate these points. Our challenge was how do you do that, right? So we're lucky in so many ways. The internet has become so incredible, and GPS tracking devices, our ability to actually follow radio collar technology, all of these things have really improved substantially. So we looked for species that had certain characteristics, but also we needed to find species that had been studied by wildlife biologists who were using either GPS tracking, radio collar tracking, so that we could get data. We needed to have lots and lots and lots of data so that we could analyze their data to ask the questions that we were interested in. You know, the penguinologists who were studying these king penguins in the first chapter, Ursula, they weren't studying adolescents, right? They had other questions, which were ecological, and I mean, they had a wide range of questions on their research agenda. But what we did was we found these animals that had research groups that had been following them and had, in the case of Ursula, radio collar data that we could interrogate. And that's what we did. So for Ursula, it was radio collar. For Shrink, it was actually, there was some radio collar, but mostly it was direct observation. For Salt, it was GPS. And for the wolf, for Slavic, it was also GPS.
They're all such cool little characters and great stories. Let me ask, this is another audience. Adolescent animals seem to die because of being inexperienced rather than impulsive, as human adolescents seem to be. How do you come on?
Oh, I think both. I didn't show, I have tons of other stuff that I'm not showing. No, that impulsivity, I think, is part of it. And actually what's exciting about this, so Nico Tinbergen, you know, I have some other slides I can show. He's such a fascinating character because this insight, right, that if you want to answer the question why, you have to really ask the evolutionary question. So impulsivity, right, you might say, well, why would, you know, what would be the adaptive benefit of something like impulsivity? Or let's say decreased fear, because we see adolescents, you know, particularly adolescent animals, including human animals, are willing to take risks when they're with their peers. It's one of the reasons why kids are not allowed to have to drive with peers in the first year or whatever of their driver's license. Well, when you look at predator inspection, you see that young animals, adolescent animals, approach predators pretty much only when they're with others. So that experience of being with others seems to lower the risk-taking threshold. But the interest in new things, neophilia, which is a characteristic of adolescent animals, from fish, you know, through rodents, through humans, and some degree of impulsivity, those neurobiological characteristics likely facilitate a certain kind of adaptive behavior. So if you're an adolescent animal, you need to learn new things. You need to leave home. You need to learn about what's dangerous. And a neurobiology that supports that, although it may be at times associated with accidents and death, overall is probably important for pushing animals out of a comfortable, natal, familiar setting. So, what we think of as being pathological, oh, the adolescent brain, they're impulsive, they experience sensations, you know, more powerfully, all these kinds of things. If you flip it and you think like a Tinbergian evolutionary biologist, and you're going to look phylogenetically, all of a sudden you ask yourself, why would it be beneficial for an adolescent to have that kind of neurobiology? What important life experience, something that they need to accomplish, would that kind of neurobiology promote?
Okay. You actually touch on neurobiology on a few of the chapters. I have a notes here that under status, you talk about depression, anxiety, and serotonin. You talk about dopamine in another context with respect to courtship behavior and motivation, and how it also relates to addiction and depression. It's nice for me anyway to pull in a little science once in a while that's not observational science, but more, you know, basic.
Mm-hmm. Yeah, let me share something, if I may, because you know, this idea that we can learn about something like mental illness from other animals was really very disruptive for me. It wasn't something that made sense. Are you able to see?
Yes.
All right. So again, going back to the central premise of my own work is that if we're only looking at a phenomenon from an anthropocentric point of view, that we're only seeing some of the big picture as we look across species and then add this evolutionary perspective, we see things much more clearly. And the same year that Tinbergen won the Nobel Prize, 73, there was an essay published in the American Biology Teacher by another evolutionary biologist, and that essay was entitled, "Nothing in Biology Makes Sense Except in the Light of Evolution." Well, if you think about mental illness, which is really a brain disease, then nothing about mental illness, nothing about any disorder makes sense outside the light of evolution. But of course, it's one thing if we're talking about physical illnesses, but there's something about the animal mind that makes it a little bit harder for us. It's interesting, Tinbergen himself, so here he is winning the Nobel Prize. He was a little boy, was born in 1907 in Holland, very happy childhood. Interestingly, his older brother also won the Nobel Prize a few years earlier in economics. Isn't that incredible?
Wow.
Yeah, smart family. He was very athletic. Here he is. Anyway, the point is he seemed to have had a happy childhood. But when the Nazis invaded Holland in 1940, he was part of the resistance at the University of Leiden. There was the Nazification of the university. He protested. He was thrown into a hostage camp and then briefly into a concentration camp. Of course, Holland was liberated in 44 from the eastern side first. And these black dots I have right here, this represents where above these lines, this was still Nazi territory. And so when Tinbergen was actually liberated from the concentration camp, and he went back into the occupied territory because his family and his 3 small kids were there, and they then endured the Dutch hunger winter, which was this awful situation where food supplies were limited. The point is he went through a lot of trauma during the war. And after the war, Tinbergen started to develop very severe depression, very, very severe depression. And actually he had several, very serious suicide attempts. So I've always wondered whether this brilliant, this genius whose contributions to thinking about why animals engage in the behavior that they do, I wonder what he thought about why he was so depressed and that sort of thing. I won't go through all of this, but I want to just kind of, I'll just give some teasers and say that many of us, I certainly, until very recently, was very reluctant to go in this direction, but really are resistant to thinking about mental illness or mental states of a certain kind in non-human animals. And part of that is a concern about anthropomorphizing. So you guys probably all read, Animal Farm, but I remember in 6th grade, and I remember my teacher explaining that, Animal Farm it's an allegorical novella, and the animals it's a political allegory, really. But the animals are given human characteristics. And I remember my teacher saying, the projection of human characteristics onto an animal, that's anthropomorphism. It's not scientific. It's so many of us kind of grew up feeling that it was very important scientifically not to anthropomorphize. And contributing to that fear is this kind of long history of the rejection of the animal mind. Usually Descartes is pointed to as the one, Descartes was a philosopher and scientist in the 17th century who really, who's divided, man and animal, the mind and the body, and believed that animals were really robotic. He actually, as it turns out, was really echoing the views of Aristotle and Thomas Aquinas. But the point is that the centuries and centuries and even millennia of traditions thinking about the animal mind as non-existent, that really endured. And even though Darwin, Darwin wrote a book called The Expression of Emotion in Man and the Animals. Now, Darwin recognized this phylogenetic continuity, when it came to morphology, bodies, and et cetera. But he also recognized that there was phylogenetic continuity of emotions. But even though Darwin himself had that view. Others did not really. And to make a long story short, there is really only recently, the behaviorists really were also part of the problem. The animal mind didn't exist. But ultimately, there, I believe, has been a kind of a priori assumption that the human brain is the only brain that the mental illness is uniquely human. And of course, that's not the case, but I think there's been kind of a lot of that kind of thinking. And, I think back to my teacher who told me that anthropomorphizing was a bad thing to do, right? And she said, it's the projection of human characteristics onto an animal. But actually what it is the projection of human characteristics onto an animal in ways that aren't scientifically justifiable. But since the 1970s, when we read Animal Farm, look what's happened. Look at the fields of science that are illuminating the connection, the deep linkage that we have with other species. I mean, neuroscience has absolutely exploded, and neuroimaging, it didn't exist in this. I mean, it was just a twinkle, a twinkle compared to what we know now. Comparative genomics has just emerged in the last couple of decades, which shows us specifically, how genomically related we are to other species, and it's far more than not. And lots of other scientific fields really are objectively showing us the extent of our connection with non-human animals. And so now I think when it comes to turning to the animal world for insights about mental health, I think one needn't be so concerned about anthropomorphizing. In fact, I would suggest that if there is a scientific mistake that's going to be made, it's actually not going to be anthropomorphizing, but rather it's going to be human exceptionalism that has made all of us so concerned and reluctant about recognizing and accepting the connections when they actually do exist. So, and I won't take much time, but just say that if you look at these fish, each of these fish is an individual, and they're social. They have a social brain. And when their status rises and falls, their social brains change, their serotonergic pathways are activated, and their behavior is modified by whether they win or lose, whether they have status descent or whether they have status success, essentially. And there's a limit to what we can learn about human moods by looking at fish, but there's a lot that I think that we can learn when a fish, for example, loses multiple bouts, let's say contests with another fish. They have elevated stress hormones. They have a change in their serotonergic activity in their brains, and their behavior changes. They become withdrawn. They're not as aggressive. And, having done a residency in psychiatry, when you read about the behavior of these fish who've experienced chronic status descent, they really sound like human beings with depression who have these symptoms what are called neurovegetative symptoms. In any event, not to belabor all of that, let's just say that I think there's a real opportunity today for us to look across species for insights, and not just into mental health and not just scientific insights, but also potentially to use the knowledge that mental illness can occur in other animals to combat stigma. Mental illness stigma still is, the former head of the NIMH has said that mental illness stigma is the foremost obstacle to progress in mental health. And I think there's a real opportunity to see mental illness and mental health through a different lens, recognizing that other species are as vulnerable as we are.
Well, that's a great conclusion. And I think we've run a bit long. So I want to thank you for what I found to be very fascinating, both the book and our discussion tonight. There are so many other things. I wanted to just tick off a bunch of terms that you and Kathryn cited in, ones that are really funny. I couldn't even pronounce one. maybe I'll just pause and let you just give a brief definition of Mamala Pinnatapai. Sorry. Just tell us what that is, and we'll finish with that one.
I think it's one of the longest words in yeah, it's this kind of look and understanding that two individuals have when kind of considering whether it's going to happen. It's a kind of assessing each other and the feeling and all this stuff. And as we were watching Animal Courtship, and the way whether it's these albatross or whether it's hyenas, and you see this kind of, is it or isn't it? You know, are we or aren't we? This kind of those moments of uncertainty. That word just perfectly captured it, even though it's unpronounceable and unspellable. And so we kind of fell in love with the word. I have to say that learning, and I really am careful to only make connections between human and animal behavior when I feel there is sufficiently shared biological mechanism to justify that kind of a conclusion. But once I start to do that, I find it inspiring. It makes me feel really not like I'm being unscientific or sentimental, but it makes me feel connected with nature. And it makes me feel, frankly, less kind of bad about my own shtick. So you know what it's like when you work on a research project and you write something, it changes who you are. So one of the big things that this project did was to kind of normalize my thinking about all the stuff that we go through that we're, you know, maybe we're embarrassed about or is tough in human life.
Cool. Any parting words? Otherwise, I'll just say thanks. We got a lot of little thank yous in the Q&A as comments at the end. And otherwise, one last thing. What's your next book?
Well, I'm really interested in female health across the tree of life. So I'm working on several projects where we are looking at postpartum depression, a form of postpartum depression that we see in horses and in sheep, where the mare rejects the foal. So that's really interesting. But we're also looking at some animals that have adaptations that allow them to stay fertile for much longer. We have this problem of reproductive senescence as females. So that's one project, but I'm really, really interested in thinking about mental health and all of these connections that I keep discovering and I'm really excited about. And even though I left psychiatry, I finished medical school and I thought I wanted to be a psychiatrist. I did a residency in psychiatry and I was like, I don't know if that's what I want to do. I went back and retrained in internal medicine. And at one point I'd sort of taken psychiatry off of my CV, but now I'm really, really interested in what we can deeply learn about mental health by looking across species.
That's great. Blending all your training in your back. Well, thank you so much again. Good luck with that. And I'll pay attention. Now I have to go buy Zubiquity. So.
Well, if any of you are physicians or psychotherapists or have an interest in participating in any of this comparative stuff, just go to my website. We have loads of students and we have tons of projects. So I suspect there are some academic people who are maybe on this call. So let me know.
Can we audit your classes?
What's that?
Can we Zoom audit your classes?
Yeah, they can do that. Or we have a bunch of projects that we do. Yeah, we have all kinds of cool stuff going on. We're just winging it, and because of quarantine, we're collaborating with people around the world and having fun and doing science. So, or
at the least, just follow you on Instagram, right?
All right, Twitter. That's all. I haven't mastered it yet.
Got it. Okay. Thank you, Barbara.
Thank you. I appreciate the invitation.
All right. Good night.
Bye.